Hello, everyone, and thanks for joining me again today for another session of Programming Daily. Today on the agenda is more wyvern and more loopback connections overlapping. So off screen, I managed to produce this spectacular success of engineering achievement. Connections are not overlapping anymore, but we're far from done. And right now, I'm implementing unit tests to sort of pin the new behavior. If I was to add another line, it would just overlap with the last one, which is this outer one. So we're far from done. The algorithm will be improved soon. But let's not worry too much about it. What we should prove now is that we can detect those conflicts a little bit better in a controlled way. So if we're just testing this function, I hope you're having a great day, by the way. I managed to make myself some coffee. I hope you're enjoying a drink of your choice as well. This session should also be pretty relaxed and slow-paced, and we'll be doing mostly just unit tests. Maybe if I have the time, I'll focus on the algorithm that shifts those connections to the right and changes the overall width of the skewer. So for the loopback conflict, let's only define one test. Because that loopback conflict function really just depends on the loopback conflict prime. And we'll focus on testing that soon. So we're testing this scenario. It should pass. I'm not too bothered by those warnings right now. Okay. So now let's focus on this. This is much more interesting. Let's maybe build it like this. Would it be better? I hope we can still see the code we're testing, but just in case you can't, we're focusing on the selected lines. This is still getting that one, but it doesn't matter really. just have 1 point here. I should have copied it from here, but it's fine. Maybe we can combine these two conditions into just one and also provide two more, simply because every loopback in this sense is expected to have 4 points. So we can just go ahead and do P2, P3 and empty. And just remove this. And everything else is a false. Okay, that depends on conditions or other conditions. So let's do too short one. We'll have one element or 1 point, 2 points, 3 points. One, two, three. I'm sorry, this got formatted unconditionally, so oh well. And just to test it, let's return true here. And this will break some tests, but it's fine. Oh, maybe it doesn't. Okay, that's good. Now what we want to cover is this. Maybe we don't even need this. So this should be true. This is probably going to break some tests. And it still didn't, okay. Okay. Let's add X to the mix. To make it really overlap, we need to compare X and X1 and X and X2. Let me just check if you can see what I'm actually typing. You can't see it. Let's just leave a position to do. Is this better? Can you see it now? You should be able to see it now. Yes. Sorry about that if my face was overlapping the code. This will probably happen again. So in that case, I'm expecting this case to still return true. No. Conversely, let's provide a condition where non-overlapping. Loopback exists. 1.1. So let's only have 3. For now. try to time to spice this up and also introduce origin y and origin and destination y. This is going to be the coordinate, the y coordinate here and y coordinate here. Let's name it y1, y2, and conversely these prime. So naturally this calling code will also change. One and y2 prime equals this. Prime, prime, prime. A little bit easier to read. You know what? Let's bring it back over to this side of the screen. And let's only have one piece open at a time, or one pane open at a time. This should compile. But it should break the tests. I can't find source for Lexer. Do we need that? Now, we're going to break some tests. So let's start fixing. So it wasn't too bad. Now let's visit the code again. And now what we want to achieve is another condition. So in our case, y1 is this. So we want to make sure that y1 is greater than y1 prime and y2 is lower than y2 prime. Not lower than equal, lower or equal, or greater or equal, or greater than or equal, because if they're equal, they will be overlapping. So we have these for conditions. Let's see what breaks now. Overlapping loopback connection. That's 184. It is here. So we have 1, 0, 1, 0. Also, the conditions should be a little bit different. X equals x1 or x equals x2 or no, that should be and. So that there is a conflict. If there is a conflict, so yeah, take it back. We need to flip the conditions. And that should be an or. And then there should be a conflict. Yes. So let's start experimenting, non-overlapping. let's assume that we have no conflict on the x coordinate, but we have a conflict on y. Non-overlapping means this would have to be 0, 9, and this also 0, 9. Oh, it's not that simple. So here really we have multiple scenarios. Can I do this? I just want to buy myself some space. I wonder how this is going to get formatted. Like this, okay. There, that works. So first of all, let's consider the second connection, this guy, being on top of the first one. So if y1 prime is greater than y1 and y2 prime is greater than so that should be 2, sorry, y2, so this and this y are greater than the top one. Or they are below the first connection, so y1 prime is lower than y1, and y2 is lower than y1. Then no conflict. Else true. Well, there are more conditions. So let's make it based on y only. Let's just go with 2. So in our case, let's tackle this condition first. When both y's of the second connection are above the y's of the first connection. So let's go 0, 0. And here for the second non-overlapping existing loopback 2, let's go with the longer connection, or the outer connection being underneath the first connection. So that would be 2 and 2. Perfect. Now, so let's add another condition here. If so the condition I want to implement is I'm going to assume that x's are always going to be equal. So if y1 prime equals to y1, but we don't need this now. Well, technically we don't need brackets here either, but it just makes it easier to read. y1 y2, or let's go with all combinations or 4 combinations. y2 prime equals y1, or y2 prime equals y2. And true, we know there is a conflict. Two, one, one. 0 and 1. And also 3. Case 1. We're going to false. Oh, let's go with true. Because, oh, sorry, false. I'm very bad at this. Y2 is here. Well, technically, we also have to provide a condition. Now the same for Y2. Now it should be false, I think. Yes. Oh, sorry. Should be false here. Yeah. Sorry, the conditions here should be false. So we go here. And I feel that these conditions should be addressed at some later stage, but for now, we have a pretty good handle on what's happening. Or you know what, maybe let's just quickly implement one more condition. So this is only not a conflict if y1 prime is lower than y1 and y2 prime is greater than we should have started with that. But it's fine. Then false. There's no clash. Otherwise, we're dealing with some sort of other combination of the connection starts here and goes here. So we're going to assume that there is a conflict. So a quick set of unit tests to confirm that. That is overlapping. So we have all ones here. What we want is this point should be this, and this should be 0, 9. Or just to signify the importance of this, y1 prime plus 0, 1. Or significance of the relationship between the points. y1, 2 prime. One, 8, 9. I think I should change the conditions here. because we're checking for overlaps. So it should be y1 prime is greater or equal and no, this is good. Oh, here I'm checking for non-overlapping. Okay, this is good enough, I think, for today. During the next session, I'll try to make this logic a little bit more sophisticated. Well, actually, these conditions, meaning that right now we're only taking the head loopback connections under consideration for loopback collisions. But technically we should take all of them under consideration simply because some loopbacks can be shifted to the right. But we'll deal with this during upcoming sessions. For today, I would like to wish you all a fantastic day ahead. Thank you for your patience and take care of yourselves, and I'll see you next time.